Scientists think Earth almost did have two moons. And then one day, one of them disappeared. Not exploded, not left. It just became part of the other one. For the last 4 billion years, you've only ever known one moon. It rises, it pulls the tide, it disappears for a few nights a month and comes back. You've never questioned it because you've never known anything else. But somewhere out there, in another version of this planet, a second moon rose right alongside the first one. And everything about that world would be different. The sky, the ocean, the seasons, even the shape of the calendar you live by. So what would actually change? Let's start with the night sky. A second moon, roughly the size of ours, in a stable orbit would mean 2 disks of light hanging over you after dark. Depending on where it sat, it could be nearly as bright as the first, or a pale, smaller companion trailing behind it, rising an hour later, setting at a different angle entirely. Either way, true darkness would almost disappear. Nights would rarely go fully black. And that changes more than the view. Humans evolved to sleep by darkness. Melatonin, your body's sleep hormone, only ramps up once light drops low enough. Add a second source of reflected sunlight in the sky, and some nights your body might never get the signal to fully shut down. Entire generations could grow up mildly sleep-deprived without ever knowing why, because the dark they needed simply never fully arrived. Every nocturnal predator on Earth hunts by contrast, moving in shadow, striking under a dim moon. A second moon means fewer places for real darkness to hide in. Prey behavior would shift. Predator behavior would shift with it, and every ancient legend about the safety of night, every myth about creatures that only come out in total dark, simply wouldn't exist. There would be no true dark to fear. And maybe no reason for early humans to huddle quite so close to the fire, telling stories to keep the black at bay. Now, the tides. This is where it gets dangerous. The moon doesn't just create beauty in the sky, it drags the entire ocean back and forth every single day. Add a second moon, and you're not doubling that pull, you're layering 2 gravitational fields that constantly shift in and out of alignment. Some days, both moons would pull the same direction, and coastal cities could see tides swelling past 12 meters. Twice a day, every day, salt water pushing through streets that were dry that same morning, the smell of rot setting into anything left behind in the mud once the water pulled back out. Other days, the 2 moons would cancel each other out, and the tide would barely move at all, leaving harbors half-drained, boats keeled over in cracked, sun-baked mud, fish stranded and dying in puddles that used to be a working port. There would be no predictable tide table, no fixed rhythm the way coastal civilizations have relied on for thousands of years. Fishing, farming near estuaries, even where humans chose to build their first port cities, all of it, built entirely around one dependable lunar pull, would have to be rethought from scratch. Some of the oldest human settlements on Earth exist exactly where they do because the tide was predictable enough to trust. Take that away, and entire towns might have been built, flooded, and abandoned within a single generation. Then there's the wobble. Earth doesn't just spin, it tilts at almost exactly 23.5 degrees, and that tilt is what gives us seasons. Our single moon acts like a gyroscope. Its gravity is one of the main reasons Earth's tilt stays locked in place instead of drifting wildly over time. Mars, which has no large moon of its own, has a tilt that swings wildly over millions of years, sometimes nearly lying on its side. A second moon on Earth, especially one massive enough to matter, would fight that stability. Depending on its size and orbit, it could either help lock the tilt down even tighter or destabilize it entirely, causing the tilt to swing over tens of thousands of years. If it swung wide enough, entire regions could tip from mild seasons into extremes. Ice sinking down toward the equator in one era, burying farmland under sheets of frost, and vanishing almost completely in another, leaving the same ground cracked and starved of rain. A body built for one steady range of temperatures would find itself freezing solid some centuries and blistering the next, with no generation ever living long enough to see the whole cycle coming. Civilizations don't build themselves around chaos like that. Everything from crop cycles to migration patterns depends on a tilt staying roughly where it is. And there's one more thing two moons would take from us: eclipses. A total solar eclipse only works because of an almost absurd coincidence. The sun is about 400 times wider than the moon, but also about 400 times farther away. So from Earth, they appear to be exactly the same size, close enough that the moon can slide perfectly over the sun and blot it out for a few minutes of unnatural darkness at midday. Add a second moon into the mix. At a different distance, a different size in the sky, and that fragile coincidence breaks. Some eclipses might vanish into partial shadow forever. Others might turn stranger, two disks crossing the sun at once, overlapping in patterns no human society could ever have predicted or planned religious calendars around. Some of the oldest recorded events in human history are total eclipses, moments so unsettling that ancient societies wrote them down as omens. Take away that one clean coincidence, and you take away thousands of years of humans looking up in genuine, synchronized awe. So if two moons would have destabilized our climate, scattered our tides, and erased our darkness, why does the question even come up at all? Because for a while, scientists think we might have actually had one. Back in 2011, two planetary scientists proposed something strange: that early Earth once had a smaller second moon, born from the same giant impact that created our current one, the same violent collision roughly 4.5 billion years ago, that's believed to have flung enough debris into orbit to eventually form the moon we see tonight. For tens of millions of years, that second, smaller moon could have quietly orbited alongside its larger sibling, trailing or leading it in a stable point in space. And then slowly, gravity pulled it in. Not a collision that shattered it into debris, a slow-motion merge, taking place over millions of years. So gradual that if anything had been alive to watch, it would barely have registered as an event at all. The smaller moon drifted closer and closer, until it simply pressed itself into the far side of the larger one, like clay folding into clay. If that's true, it would explain something scientists had struggled with for decades. Why the far side of the moon, the side we never see from Earth, has a thicker, mountainous crust, sitting several kilometers higher in places than the near side, while the near side is thinner and covered in smooth volcanic plains. One moon absorbed the other, and the seam of that collision may still be sitting up there right now, written into the mountains on the side of the moon no human has ever seen with their own eyes from the ground. A second moon didn't disappear by being destroyed, it disappeared by becoming part of the very moon you look up at tonight. Which means somewhere buried inside the moon you've known your entire life, there might be a second moon that never got the chance to exist on its own. Every full moon you've ever watched, every tide it pulled, every sleepless night under its light, all of it happened because that second moon lost. Its rock is in there. Its gravity is gone. Its light never got to reach you. You've spent your entire existence under a sky that could have looked completely different, orbiting a planet that could have been shaken apart by two competing pulls of gravity. Its coastlines drowned and starved by turns, its seasons swinging between ice and drought, its nights never fully dark. And you'll never know that other version of Earth because the version where that happened either never stabilized long enough for anything like you to exist, or it quietly resolved itself into one single, dependable moon, long before the first human ever looked up and wondered what was hanging there. So the next time you look up at a clear night and see just one moon, calm, steady, exactly where it's always been, you're not looking at simplicity. You're looking at the survivor. You're looking at the version of the sky that had to win so that a version of you could exist to notice it at all.